not going to be paid off because they have degrees, PhDs, mind you, in applausology. So they are above being paid off because physics is, you know, the best. But they are above all bribery, and they are going to be objective, and they will be using science to find out who's the best.
Okay, so we have these guys here, but the really fun thing is the prizes are going to win. The demo that wins the most applause, as calculated by $12, are going to win this fantabulous trophy for the Saturday Science Festival. Majestic, glorious.
The best part is whoever wins gets to show this off in their department for the next year until we have the next one.
Bragging rights.
Bragging rights.
Bragging rights.
Yeah, and then you can just look down on the other sciences and just say you're better. We all do that anyway, so. All right, so fantastic. Well, let's get the show on the road. Welcome to the Savvy Science Spectacle, everyone. Yeah.
All right, guys. So first up with the Chemistry Club, showing us some fantastic demos.
Great. So, what are you going to be showing anyway, Patrick?
Well, I don't actually know exactly, but I did hear it's going to be a bit of a blast.
Okay, so what's it called?
I believe it's called the something about gun con, I believe.
Gun con. So don't tell me that they're going to take like fun to shoot out bullets with a gun. That doesn't really sound that great.
No, dude, I think it's going to be a little more exciting.
A little more exciting? All right. So, well, here's the Chemistry Club with their gun con demo.
All right, so let's get this night started off right with a proper chemistry demonstration. What we have here is some lovely cotton. It's nice and white and fluffy. Maybe you can make a pillow out of it. But you got to remember this is Chemistry Club. It's no ordinary cotton. We soaked it in some concentrated nitric acid, which attached nitro groups to the gun cotton fibers. Ever heard of TNT, trinitrotoluene? The nitro is the key. When you've got the nitro attached to this cotton, it provides oxygen that allows our fuel, the cotton, to burn in a far more interesting manner. Normal cotton, when you burn it, you get smoke and smelly ash. Gun cotton, when you burn it, let's just see what happens.
Which line the lights off?
The lights didn't move either. All right, if we need a countdown. 3, 2, 1. All right, can we get some lights? And as you can see, I really don't have anything left. It burned so completely, it went straight to carbon dioxide, water, and nitrogen gas. So there you have Gun Cotton from Chemistry Club, a mild explosive.
Well, okay, that was pretty awesome. That was pretty cool, man.
Yeah, that was really cool, wasn't it?
Yeah. I mean, dude, it was cotton. It exploded. It's amazing.
Well, so our next demo is from a society physics student, and it's going to be a great one. Wait. So to get it started though, so I'm going to kind of give a presentation. Can you just start spinning for me?
Yeah. Okay. Yeah.
product of how heavy you are and how fast you're moving. So a bullet has a lot of momentum, but an elephant walking at 2 miles an hour also has a lot of momentum. So then angular momentum is a product of how hard something is to rotate and how fast it's rotating. And we know that angular momentum is conserved, and that means that if something is spinning, it's going to keep spinning. So if I'm spinning these, it's not very hard at all to keep them spinning. But if I want to change which direction they're spinning, I have to apply force, or torque, which is the rotational equivalent of force. And that's pretty cool, because if I do this, from your perspective, they're spinning counterclockwise. Now if I turn around, they're still spinning counterclockwise. I have to make underhand figure eights, whereas over here, I have to make overhand figure eights, because angular momentum is conserved. All right, so for this next part, I'm going to ask for a volunteer from the audience. Okay, so you're going to sit on that stool with your feet on the wooden part. Okay, now hold this out like this, all right? Now I'm going to give it a spin, and after it starts spinning, you're going to tilt it either this way or this way. I'm going to let you decide, all right? All right, go ahead. Now tilt it the other way. How does that happen? I'm not pushing him. I'm not doing anything. What? It is magic. No, it's actually science. Because it started spinning this way, he initially had no angular momentum. So if he tilts it one way, he's going to spin to counteract how the wheel is spinning, so that he still has 0 angular momentum. I'm going to ask you to do one more thing. Okay, so I said angular momentum is a combination of how quickly something is rotating and how hard it is to rotate. Do you think that if something is longer, it's harder or easier to rotate than if it's shorter? Okay, all right. Well, with that in mind, why don't you sit back down? And I want you to take these weights and hold them out at arm's length, okay? All right, I'm going to give you a little spin. And after I give you a spin, I want you to take your arms and bring them back in, all right? You got it. Now bring them back out. When he has his arms out here, he's a lot harder to rotate than when he has his arms in here. But because he has the same amount of angular momentum, because he's easier to rotate when his arms are in here, he's going to spin a lot faster. Even though I'm not touching him, I'm not spinning him or speeding him up. Physics. All right.
Well, Patrick, did you get a little dizzy from watching that as well?
I think I'm still dizzy from the spinning that you do.
Oh yeah. So what's next on our agenda?
Well, let me illuminate you on some of the demos we've got coming up.
Oh, are we starting a light pump section? What are you trying to tell me?
What? I get it. That's brilliant.
Because that's a real light-hearted joke.
Okay. Before we get too funny here, let's get the luminol demonstration with the chemistry department going.
All right. Oh, hey, not bad.
All right. So you remember the Matrix, right?
Oh yeah, with that little band, it was like. Yeah. Okay. Yeah, I remember that.
Cool. Awesome. And you know about lasers, right? They shoot straight, right?
Yeah, pretty sure, yeah. Yeah, they burn through things and they, yeah. Iron Man does that. Yeah.
What if I told you? What if I told you that we have the power, the technology to make light bend?
So you're telling me that light would win in a
pour the water? So just pour the water. I fill it. What's happening is the laser is going inside the water and it's being internally reflected. So it's hitting the edge between the air and the water and it's being reflected back inside the water. So it's getting reflected most of the way down. We call this the liquid laser dome. Thank you.
Interesting topic.
Jake, you gotta stop with the lifetimes, man. We've done the math. 0% of this population likes puns.
So what you're saying is, if we stop doing puns, it will brighten up everyone's day?
No, just stop. Here's our next demo before he starts up again. Here's Todd with the Society of Physics students on electricity and induction.
Wait, what if I use less frequency? They'll be pulled to new lengths.
Here we have an electromagnet. And once we get some power. Alright, great. It'll induce magnetic fields. So when I take a metal coil like this, place it like so, and launch one of these rings up in the air. I see this one right here is a full ring, and now I have this ring here with these notches in it. Not as high up. This one has just one little notch in it. So we got the highest with the one that was the full ring, not as high with the one notch, and then the lowest one was with these two notches. So what's happening here is this is inducing magnetic fields, and which is inducing a current in these coils. The current spins through the coil, which creates a force upwards. Now, I'm going to take one of these coils and put it in some liquid nitrogen. Any ideas on what's going to happen? It's going to go lower. Any other ideas? All right, we have one hypothesis that's going to go lower.
Maybe it's gonna shatter.
It's going to shatter. Hit the ceiling, so it'll go much higher than before. This is the full ring. This is the one that went the highest. All right, let's see what happens. And that's really cool. I don't really want to touch it. So what happened? It went a lot higher. Any ideas why? So anyone heard of superconductors? Yeah. Yeah. So what do we need to do to create a superconductor? You need to make it really cold. So because the electrons can flow a lot easier inside of those cold materials. So because of that, I remember I mentioned the current is going through those coils. Well, so what? You have an idea for me? What's your idea? Don't be shy. Okay. So the electrons are spinning faster through that coil, which creates a greater force upwards. All right, thank you.
Well, geez, come on. She should just come up and do this for us. She's so smart.
All right, well, let's see.
All right.
Don't try this at home.
Oh, and by the way, guys, liquid nitrogen is cheaper than milk. So, just saying, if you ever have milk money, just buy liquid nitrogen instead.
Slowly but surely.
Slowly, slowly. Well, you know, we could always just go grab more liquid nitrogen. I mean, I'm down. Can we get some more in there?
Probably.
All right, let's get this. I feel like we need the circus music. But
I feel like you need to learn the difference between need and want.
all right, do you think it's about time to, well, I think we can get the rest of these in there.
I think all of them popped in there.
Well, you know, that's definitely a possibility.
Did you hear a pop?
It must have quietly.
Maybe. It's definitely a possibility.
Think we can fit one more?
I think we can fit one more.
All right.
All right, everyone, drum roll. All right, just a little bit longer. Now, pat your heads. Oh my God, this is great. All right. Wow. 6 balloons into here, fully loaded up. Now for the real fun part. They expand back out. Oh, that's no fun.
I disagree. I'm having fun.
That's a lot. Yeah, exactly. Here. Bring it up a little bit. It wasn't that bad. I just really want to throw it in the air. They can come back! How cool is that?
I'm deciding to explode first. Dude, I gotta shake your hand. It's fantastic. Thank you.
No, I'm not going to shake your hand.
But I bathed and everything.
Dude, smell it. No, dude, I don't know what you did. No, that's gross. No.
What's the deal, man? Yes.
Well, here, okay. Let me show you, or actually more biology, show you exactly why you may not know how dirty you are.
And Is that what you got?
That's all I got. That's all I got. I'm not going to, no.
There's no, is that all else you got?
No, that's not, is it? So, also on top of that, they got another fun one that they're going to show you exactly how your digestive system works. And it's going to be awesome, might be a little gross, and it's going to be great. All right, so everyone, here's the biology department.
How's everyone doing? Thought about how fast germs are spread, or how many times you're in contact with someone else during the day? Anyone? Ebola, right? Actually, now that I think about it, probably half of you, or more than half of you guys, actually touched the doorknob as you're coming in. That's how germs spread. I'm not trying to scare you. You're not going to be sick, but just trying to let you know. So what we're going to be doing here is we're going to be doing a demonstration, but I need your guys' help. So I got helpers on each side of the aisle. They're going to come to each row, and they're going to come and tell you guys to maybe walk out to the aisle, and they're going to just kind of give you guys a little bit of lotion. We're not going to tell you whether it's the germ lotion or whether it's the real. And don't worry about it. It's not real germs. It's all an imitator, okay? So don't freak out, and obviously if you guys don't want to do it, just stay seated and just watch. But during that, what we're going to be doing is going to show you how food is digested through your system. I mean, yeah, you eat something and you're just kind of like sitting down, watching TV, it's all doing its own thing. But we want to show you what exactly happens. So basically, we're going to give you guys a demonstration of how food goes from your gum right out to your bum. Ready? Let's do it. Okay, so let's do a little specific anatomy right here. See this right here? These are your molars. These are what grind up your food, right? You guys know what molars are? Yeah? Okay. And we got your incisors. Those are whenever you're taking a bite out of something, that's what you tear the food off with. So those two are very important in the digestive system, especially in the mouth. So here we have our friend Andrew. He's been invited to a barbecue. You know, he's socializing, having some food. He's having some bread, you know, just kind of munching on bread, as you see over here. And he's biting it all with his incisors because that's what he uses to tear the food, right? Next thing, he's like, I want some hot dogs. So he goes out and grabs some hot dogs and he's just munching on them, you know, just having the time of his life, just eating all this food for free. And then, I mean, you gotta have chili, right? Chili is a big part of any person's diet. That's all good stuff. So we have chili here, baked beans and beef. There you go, put it in there. Don't worry, right? And then, I mean, you gotta have a drink, right? You gotta have some soda, the good old Dr. Dynamite, as they call it. So right now, this is all happening inside your mouth. And it's all going to be just primarily munched up and teared down just to like do the initial breakdown of the food in your mouth. And let's not forget, we got saliva. Saliva is a huge part. You're not just taking a bite out of your food and you're just kind of biting on it like just dry. There's got to be something that is kind of softening it up and making it easier to just kind of digest and break it down through your esophagus. So right now, Andrew is grinding some with his molars. We'll give him a little minute, you know. Actually, I got a joke for you guys. Which is better? Doing homework on a full stomach or on an empty stomach? Anyone? I don't know. What is? Someone? Nope. Wrong. You do your homework on a paper, not on your stomach. Huh? Huh? So just as this is going on, what's going to happen, we're going to transfer the mouse. It's the same mouse, but we're going to put this in a bag right here. Yeah? As you see. Yeah, right? This isn't your guys' mouth. This isn't your guys' mouth, so.
So, now that this is all in the back of your mouth, you gotta swallow it, right? So, from the next step, you take all this in the back of your mouth, and you're gonna swallow it, and it's gonna go down your esophagus and into your stomach. So this is what it looks like when you guys swallow something. Just comes draining stomach, it's churning around, it's bubbling. But wait, there's more than just a sac. You gotta add in some acid, some stomach acid. All right. Yum. Okay. Now that there's stomach acid in there, to further break down things, stomach acid is going to activate enzymes. This is specially made enzymes just for this demo.
Only the special kind for biology.
This costs like $300. All right. Now that it's bubbling and churning and all the food in there is being broken down, it's now being converted into something called chyme. So from there, the food in your stomach is going to go into the small intestine. And this is going to be where all the nutrients are going to get absorbed into the bloodstream. This is our small intestine.
Stomach, not incisors anymore, and your small intestine.
Oh yeah.
Ah, look at that. Okay.
So now that we have all this in our small intestines, it's quite acidic. So we need to neutralize the stomach acid with sodium bicarbonate. Let me just open up my, there you go.
Small intestine.
Small intestine. All right. And now we need to add more enzymes to further break down. You know, it's quite a process. You don't eat a sandwich and it doesn't come out as a sandwich.
At least I hope not.
Most of the time. Now we have to add some bile salts, and this is going to help break down the fats. Just keep the process going, keep the process going.
How many of you had food before you came here? This is all happening in your stomach right now. Yeah.
Now, we got to add some bile pigment. This is broken down red blood cells, and this is what gives your food that nice brown, luxurious color. Oh yeah. So as you can see, it's all leaking out here right now. These are the nutrients and all the enzymes just pushing things into your bloodstream. So I'm just going to get some of this in here.
Oh yeah. Look at that.
So, Papa, show them what it looks like to actually put this in the bloodstream.
Ready?
That's coursing through your veins. But wait, now that we got all this just hung sitting in your small intestine, it's got to go somewhere. So now it's going to travel into your large intestine, and from there, the rest of the majority of the moisture, the liquid, is going to get absorbed. So, do me the honors, go into the small or large intestine. Get this in there. There you go. Ah, so good. So now, the large intestine is taking out all of the excess liquids, and from there, it's going to get transferred into your rectum, waiting for you guys to go to a toilet, a hole, or whatever it is you guys do.
Our little representation of the rectum.
I'm sure someone's rectum is okay.
Yeah.
All right. So now, you finally made it home, or rather, I guess this is me. So I finally made it home. It's the next day, and, you know, I'm ready to go to the bathroom, getting a little bloated. So, Saba, do the honors.
Can we get a little squeeze in 3? 1, 2, 3. And that is how the digestive system works. And by the way, you see this here? Watch that there. So, without farther ado,
Foam. That's so last week. Explosions.
So what, are you like a hipster now?
No, I'm just saying that they're just too mainstream. They're done. Explosions now. They're the hit thing.
Yeah. So wait. So are you going to tell me that these explosions are underground?
No, Jacob. I'm pretty sure everyone here knows what explosions are. Are you telling me you don't know what explosions are?
You're a jerk.
I mean, yeah. But
Well, here's the chemistry club with some more potassium permanganate pyrotechnics.
nice. That's alliteration. Good.
Thank you.
So what we have here is a mixture of ethanol and hydrogen peroxide in this dish. Ethanol because it's an alcohol that will burn, and hydrogen peroxide because, like Morgan mentioned, it can decompose into water and oxygen. So we're going to add to our hydrogen peroxide ethanol mixture a gram of potassium permanganate, which is going to speed up the decomposition of the hydrogen peroxide. And before we do that, we're going to light the ethanol on fire, and we'll let you see what happens. Ready? Sure. Somebody goes over like Blast shield is for your own safety. Chris, give him a countdown. In 3, 2, 1. Thank you, ladies and gentlemen.
Let's see, 1, 2, 3, 4. Okay, 4. We got it. We're good.
All right, man. I gotta tell you, I'm a little all these fire terms. I'm a little burned out. No, sorry. I'm so sorry. Please stop it.
Hey now, guys. Let's not get too hot-headed.
You want one?
No.
All right,
okay,
that's
I'm
what I
sorry.
thought.
I'm sorry. So, we'll be good. Don't worry. So, let's step away from the fire and thus the fire funds. Here's the business club with their ping pong cannon. And where we're going, folks? This one may be a little loud. Here, Muffs.
So this here is our ping pong cannon. Why is it a ping pong cannon? We have a ping pong ball lodged at about right here on this side of the tube. We have a vacuum pump right here. When we turn it on, it sucks all of the air out of this tube, creating a vacuum on the inside. When all the air is when all the air was out of the tube,
Then we puncture a hole on this side, and all of the air goes in really, really fast and shoots a ping pong ball through that end.
therefore blasting a hole through the can to have down at the other end.
Probably don't want to stay there. And fire.
So, as opposed to the betterment of mankind and the natural just evolution of science?
I mean that's cool too, I guess, but come on, it's like loud and exploding, it's awesome.
That they are my easily entertained friends. And the next demo then should excite you even more. There's a chemistry club with something called a whoosh bottle.
A whoosh bottle? Freaking what is that?
I don't know. I guess we'll find out in just a moment, huh? I guess if you're going to hold the ball and go whoosh. Right? Woo! All right, here's chemistry club.
All right, good evening, everyone. My name is Kevin. Today I have a demo for you, and we're going to be looking at whoosh bottles. So here I have just a regular old water container, and in this container I have about a little bit of 95% ethanol with some sodium chloride. Now the sodium chloride is going to be the addition of sodium chloride is going to be in there just to give that color for you. So I'm going to add a little bit more to it. Yeah, we'll dim the lights. So I'm going to swish around. And when I'm swishing around is I'm trying to get a thin layer of ethanol in the bottle. The ethanol is going to start evaporating, causing some gas. I'm going to put this flash shield down for you guys. It's going to be loud. Assistant Chris here will light my fire stick. Can we dim all the lights? You. I'm going to take this. Combustion reaction. The 95% ethanol is very flammable, as you can see. And so what's making the noise is the fact that the gases are coming up through the tube, and then the flame is shooting up through it, making that loud noise and producing the fire. All right, thank you.
All right. Great job, chemistry. So next up, we have the chemistry department again with one of the most terrifying, absolutely terrifying demonstrations I've ever seen.
Terrifying. Really, truly terrifying. How do you mean?
Well, let me tell you. In this demo, they're going to burn money.
In this economy, no! No!
Don't worry, don't worry. No money will be harmed in the making of this demonstration. Speaking of that, can I get 20?
Yeah, that's anything for science.
Thanks.
Oh.
We got it. Here's the chemistry club, guys.
No blast shield this time. We have a dollar bill, not just 20. It's been soaking all day in a mixture of 2-propanol, which is an alcohol, like the rubbing alcohol you can buy at the store, that has a very low burning point. We also have water and sodium chloride. The sodium chloride, like I mentioned before, is to give the flame color. Sodium metal will burn with a bright yellow color, and the alcohol normally burns the colorless flame. And the water is to soak into the bill, into the fibers of the bill. So the alcohol is burning at a lower temperature than water evaporates at. So we'll let you see what happens if I can get somebody over here with a match. And go ahead and get the lights, guys.
have the physics department with one of their hottest demos.
I swear, say if you bust up any more of these in several months.
No, I swear, there's actually a lot of fire in this one, and some hot beats.
Alright, okay, so what? Is this an EDM concert now? Is that what's happening?
Yeah, man, talking about dance song. Yeah. Oh wait, yeah. Get a long way going.
Let's just turn it down. Turn it down.
For what?
Yeah.
What?
Yeah.
What?
Second, maybe.
Here's the physics department with the Rubik's Cube. Yeah. Let's turn these lights off, huh?
So does everybody know how waves work? So basically, in air, which acts as a medium, when you talk, your voice acts as a wave. That's how you can hear it and pick it up. I'm going to do something similar here, using what's called a wave generator. A wave generator will take a frequency and then play it with the Rubik's Cube.
Yes.
Always takes a little while to set up.
Oh. You need a light back on? Alright. You got fire there. You got light. Yeah. See, this is the fun part of science, setting everything up. Yeah.
So what you're going to see is where you have just everything's the same line. But as I turn up the frequency, you're going to start seeing what are called nodes and antinodes. Open another one. There you go. Kind of see it there. Go a little higher. Where you're getting these peaks. It's your wave. Peak a little more. There we go. So you can tell that this wave has a lot of different peaks. Now at all these different spots here, where you don't see any waves at all, that's where the wave is hitting the top and the bottom, and they cancel each other out. The other spots are doubling. Go a little higher. Alright, we can see another one. Now, just so you guys understand how this works with voice and music as well, instead of using a frequency generator, I'm going to use some music.
See how you can see all of those waves?
How about some AC/DC? Yeah.
Oh yeah, we can take requests. Daft Punk here in a second. Oh, this is an advertisement.
Personal favorites.
Wow. Glad you're not getting to decide who gets the award. That's a little biased.
Hey man, I am totally impartial. Every single demo we've seen so far has been fantastic.
That's true. That's true. So without further ado, here is our...
Wait, guys, wait. We're forgetting about the chemistry club and their balloons.
No, we're not.
That's what...
Just listen to this.
Without further ado, let's get the last demo out here. Chemistry department and their hydrogen oxygen balloons.
Yes. They're going to blow up balloons, and it's going to be great.
All right, how is everybody doing tonight? Ready to see something explode? All right, what I have here is the physics department. They were a little incorrect there. This is just a hydrogen balloon. There's no oxygen in here. We have put some metal, strontium metal, to give it a little bit of color instead of just a typical orange flame. So it's a combustion reaction, so we should get a nice big pop. And with that, if I can get Chris out here with an ignition source, and if we can dim the lights, we can see the color change. Does anybody have an idea of what strontium color will end up being? Red. I heard red. We're going for red, so let's see if we get red. I need the boomstick. Yes, my boomstick. They can light it.
Provide your own fire.
All right, if I get a countdown, go with 3, 2, 1. Oh no! All right, second time, we're getting this to work. We can keep the candle lit. All right, try it again. 3, 2, 1. All right, we're going to try this a couple more times. We're going to get I think lithium is next. We're going to do the same thing, but we're going to do it with lithium to get a different light. It should hopefully be a different color of red. Right. Blowtorch seems to work well. All right. See if we can get a countdown. 3, 2, 1. All right, how many of you guys out there are Seahawks fans? They're gonna go Hawks? All right, next one we're gonna do. This one's copper. Copper is going to emit what color do we think? Blue or green? Green. All right, last one, guys. 3, 2, 1. Eventually, in time. How much closer do you need to get? Copper was a fail. That didn't work. All right, thanks, guys.
Making much mess up here, aren't we? Seriously. Right? All right, everyone. I hope you all had a blast tonight.
Stop.
Okay. That was the last one, I swear.
Okay. Well, we're very nearly, we're so close to the end of the show. There's really only one thing left to do.
The Robo Boogie?
No, Jacob. No. Jacob. No.
award ceremony.
Right,
Presentation.
oh, the fantabulous trophy.
Right, okay, okay.
All right, so can we get the applausologists up front?
Applausologists, assemble!
It's been here the whole time.
All right, so now it's time for you folks to do your awesome audience thing. We need you guys to cheer for your favorite club. So which demo is your favorite? Let's start with biology. Tell us, what did you think of the biology's excellent demos?
All right, and then finally, how about physics? So, applausologists, go ahead, go in the back, do your number crunching, and let us know what you find. Yeah, this is.
Don't touch it. What's wrong? It's awesome.
Touch it! Touch it!
Probably wood and. That does not smell good. No, everybody. No, I'm pretty sure I smell better than that. No. You have to use long division. It just gets tedious. Are we ready?
We have reached a consensus.
Oh man, anticipation.
It was close. It was close. Should we work from the bottom up, or should we just call the winner?
You know what? Let's work from the bottom up. No.
No, wait, how do you want to do it? It's up to you.
Bottom up. I was going to say, or we can all get the drum roll going again, and then we can just call out who the winner was.
All right.
How's that sound, everyone?
Yeah!
Yeah, they like drumming. That's what it is.
That's a pathetic drum. Come on.
Yeah.
There we go. And by a close margin, our winner, chemistry, with 100.
So close.
We should have run it through this too. Spicy.
And then in third place, we have geology with 100.67, followed by biology, sorry guys, 96.33.
All right, so we have from the chemistry department up here. What was it? Everyone out here? Or? Oh, okay, awesome. So guys, on behalf of the Society of Physics students and scientists all around, I just want to say congratulations. You're so close. We'll get you next year. And here's a trophy. Be sure to show it off very proudly and whatever. All right. Would you like to say a few words? Say. Not really. Good. Thanks.
Folks, I'm sorry, I have to say there's one, we have wide views, that's what science does in life.
All the time.
We have one more demo. However, this is a demo so explosive, so extravagant, that it cannot be contained in the confines of this theater. So, for the final demo, the thermite reaction, I would like to ask you guys to please kindly file outside.
This is just the sparkler, and it's just to get the heat that we need.
Yeah, I remember that was outside the other building.
There we go.
Yeah, it's shooting.
And there we go. Now that is molten iron coming out the bottom. And that's what's 2,500 degrees Celsius.